Hello everyone, my name is Dr. Aizon.
And I am Dr. Jethro.
And I am Dr. Vren.
And this is
Chemical
Time. And we are here to discuss about Chemical Kinetics.
Now, what is chemical kinetics?
Chemical kinetics is a field of chemistry that deals with the rate which chemical reaction occurs.
Beside information about the speed at which reaction occurs, kinetics also sheds light on exactly how the reaction occurs.
Do you know the collision theory?
Yes, I do. If I remember correctly, collision theory states that molecules must collide to react.
Yes. Also, there are two types of collision, the
Effect-
effective and ineffective collision.
Effective collision is the collision that leads to formation of products, while on the other hand, ineffective collision is the collisions that do not lead to formation of products.
In order to have an effective collision, particles must collide at the right geometry and with enough energy, which is also known as activation energy.
Now, let's have a slight change of topic, shall we?
Yes! Now, we shall discuss about reaction rate.
There are four factors that affect rate of reaction.
These
Are
are
temperature. Higher temperature means particles collide with greater kinetic energy.
Surface area. Increased surface area means greater chances of collision and therefore faster rates.
catalyst. Catalyst speed up the reaction but not being consumed.
Finally, concentration. A higher concentration means faster reaction because of more particles.
We can compute for the reaction rate using this formula.
Let's try it out. Let's solve this problem given. Concentration final is equal to 0.00846.
Concentration initial is equal to 0.0101.
Time final is equal to 100 seconds.
Time initial is equal to 50 seconds. Let's find the change in concentration and time and divide the change in concentration by the change in time.
Now, we arrive with an answer of 3.28 times 10 raised to negative 5 mole per second.
Now let's study. Rate
Rate
law!
law!
Using the rate law, we can find the order of the reaction with respect to each reactant and the rate constant.
Now, let's see the rate law.
In this equation, A and B express the concentration of the species A and B.
X and Y must be determined experimentally. Also, this defines the order of the reactant.
While K is the rate constant of the reaction.
Now let's try it out. Let's solve this problem.
Experiment 1, 0.08, 0.34, and the rate is 2.2 times 10 raised to negative 4.
Experiment 2, 0.08, 0.017, and 1.1 times 10 raised to negative 4.
And experiment 3, 0.16, 0.017, 2.2 times 10 raised to negative 4. First, since we are finding the order of S2O82 positive, we have divided experiment 3 by experiment 2 in order to cancel out I negative.
After a series of cancellation, we arrive with 2 is equal to 2 raised to x.
Now we shall get the value of x, which we got as 1.
We shall now conclude that S2O82 positive as a first class order reactant.
Now, since we are finding the order of I negative, we shall now divide experiment 1 by experiment 2 because we are aiming to cancel S2082 positive now, since we know now x.
We now do the same. We shall cancel out. Now we get 2 raised to 2 is equal to 2 raised to y.
Now we get the value of y, which is 1.
We shall now conclude that I negative is also a first class order.
Now we shall get the value of k. We shall substitute the variable we got from solving x and y in the experiment 1.
We shall also test for the other experiment.
Now we got the value of k as 0.08088235294.
Now we shall tackle
Reaction mechanism.
Reaction mechanism is the sequence of events that describes the actual process by which reactants become products.
reaction may all occur at once or through several discrete steps.
Each of these processes is known as an elementary reaction or elementary process.
The rate law of an elementary reaction is directly based on its molecularity or concentration.
The molecularity of a process tells how many molecules are involved in the process.
And that's all for today. Please continue to tune with us. I am Dr. Aizon.
And I am Dr. Jethro.
And I am Dr. Vren.
And this is
Chemical Time.